Hello. Today's video is primarily designed to demonstrate the capabilities of a motor shield card, which might seem quite mysterious to some, but really saves you an awful lot of grief when it comes to building the types of drivers that you would need to drive a unipolar type stepper motor, pile of transistors and stuff, and makes it so easy to handle a stepper motor because you can just quickly connect them with a screwdriver to the lugs on the board and you're up and running. Basically, each motor controller board has 4 of these H bridges. I've drawn 2 here, and the switches here are implemented as transistors so that the computer can control them. And current can flow from positive one way through the motor and from positive the other way through the motor, depending upon how the computer turns these switches on. It always turns them on in pairs so that current flows one way or the other through the motor. In this case, for this example, I'm going to be demonstrating unipolar mode, which will look like this for our demonstration. And here we're only using the top half of the H bridges, these 2 switches and these 2 switches for this half of the motor controller board. Actually, for this demonstration, I'll be using both sides of the board because I have basically 2 demonstrations set up, 1 motor and 1 pile of LEDs. So, connecting up a 5-lead stepper motor with 4 coils and a return ground to the center screw. I have a motor that is designed with 4 coils. You can see that here. Very simple. I have a motor shield card, and then I have a pile of LEDs in my project board, which, if I line up correctly, will look pretty good. And now I'll start it up, and we can watch what it does. So it's doing what's called in the libraries single coil or single coil, and it's turning one of the coils on at a time in rotation as it steps through the sequences driving the motor. In the next technique that you can use is to turn on 2 coils at the same time, and 2 coils gives you, and here it is, 2 coils, gives you twice the torque and twice the braking power, so it is commonly used when people need to get a little more energy out of the stepper motor that they're using. The third technique that the motor control libraries allow you to, the motor shield libraries allow you to use, is called interleaved. And interleave is what the, beginning now, is what the stepper world people refer to as half-stepping, because it turns on 1 coil, then 2, then 1, then 2, and actually gives you, in this case, 8 steps all the way around the circle, which is twice as many steps as you would normally have, and each one goes half the distance in rotation. So called half-stepping. So interleave equals half-stepping. In the current one now is being displayed as micro-stepping, where pulse width modulation techniques are being used to slowly turn on one of the coils with respect to time. It's on more and more, and then the previous coil is off more and more. But by turning them on and off very quickly, that gives the illusion that one magnet gets stronger and the next one gets weaker, and it allows the motor to turn in very small steps, and off you're running. I'm going to move the camera over to watch the compass now. The compass is now doing the single stepping, each time going 1/4 of a step around. If I had the ability to do double stepping with 2 coils on at a time, the pointer would point here, and then it would point here, and then it would point in this direction between each one of the coils, because there would be 2 coils on at the same time. It can't do that. Now it's doing micro-stepping. And micro-stepping again has only a single coil on at a time, but it's alternating between them so quickly that it isn't really hurting my power supply. But I can't demonstrate either double or interleave, because in those 2 modes, or that interleaved is half-stepping, I can't do those because in those 2 modes 2 coils are on at the same time, and my wimpy power supply can't seem to handle 2 coils being on at once continuously. So I can only demonstrate single and micro-stepping, and this is the micro-stepping case. And this is my wimpy power supply, of course, for penlight batteries. Thank you very much for watching. Enjoy.